ladies, so here is part 2 of my polynomial introduction. We'll be covering adding, subtracting, multiplying, and dividing polynomials. So before we get started, I want to talk about two very important parts of this. You want to make sure that you're combining like terms. We need to have the same variable set up if you hope to combine anything, okay? And then the last piece is you want to make sure that you're writing everything in standard form. And standard form is something that I went over quite a few times in my first video, so if you don't understand what standard form is, go watch that video. It's nice and quick. So let's get started. Let's see, number 1, we have an addition problem. Something that I like to do is, instead of going like 3x squared plus x squared, I like to just try to simplify everything that I'm writing as soon as possible. And I found that doing this actually helps when we have subtraction problems. And as you can see, I wrote here, watch out for subtraction problems. So if we just start doing it the way that I'm going to show you, I think it'll actually help you guys in the long run. So when it comes to addition, nothing really happens to this second portion, right? It doesn't change signs, nothing like that. So we don't really need these parentheses to be here in terms of having an addition problem, right? So I'm just going to write this. So I have 3x squared plus 11x plus 4 minus 5x plus x squared minus 13. And I was able just to write that second half because we know that addition will not change the signs, right? So let's go through and let's kind of combine what we can, right? So I have x squared, that seems to be my biggest exponent here. So we have 3x squared plus x squared, that will give me 4x squared. Now let's look at what we have next. I have an x, right? So I have 11x minus 5x. That will give me 6x. I'm going to cross them out. And we have 4 minus 13 left. That will give me a negative 9. And if you feel confident with this, feel free to speed ahead. Maybe watch when I do 3 and 5. Those will probably be the tricky ones. So I have another addition problem for number 2, so I'm just going to drop my parentheses. So I have 9n to the third minus 4n squared plus 2n minus 10. And we know that this addition symbol here is not going to do anything to this second portion. So I'm just going to write out minus 2n squared plus n plus 7. So let's go ahead. Let's identify what looks similar. So I have 9n to the third. That seems to be the only, that's the only third. Yeah, okay, that's the only one. So I got 9n to the third. Going to cross them out. Let's look for squared. Here's a squared. Here's a squared. So negative n squared minus 2n squared will give me a negative 6n squared because we're just getting more negative. Cross them out. I have a 2n and an n. So 2n plus n will give me 3n. And again, we're just combining coefficients, we're keeping the variables to be the same. And negative 10 plus 7 will give me a negative 3. There we go. Alright, so here are the ones I want you guys to make sure you're careful with. So, negative signs do change the sign for everybody here, okay? So, the way I prefer to do it, instead of doing 5k to the third minus 2k to the second, that might seem easier for you, and if you're good at this, go for it, but I've seen kids make so many mistakes because they forget to change signs. So I prefer to change all the signs in the beginning. It's just a personal preference, and it's something that I've just noticed throughout my last, 4 or 5 years of teaching, right? So I have 5k to the third minus 2k squared plus 2k, and we want to distribute this negative sign to everybody right here, okay? So I have a negative times a positive 2k squared, so it'll be negative 2k squared. I'm going to distribute my negative again, so minus 2k, and I'm going to distribute my negative one more time, so minus 17. And now I'm going to combine just like I did before, right? I'm going to look for my biggest exponent. It seems that this is my biggest exponent right here, so I have 5k to the third. Going to cross them out. Looks like my quadratics are next. I got a negative 2k squared minus 2k squared. So negative 2 minus 2 gives me a negative 4. And again, you guys could pause me and then, just fast forward to my answer, whatever you want. I have a 2k minus 2k. That clearly cancels out. and a negative 17. All right. We're going to do the same thing for number 4. So I'm going to be distributing this negative sign to everybody right over here. So theoretically, I'm just changing their sign, right? Flipping the sign. So I have this first part. So I got y plus 4y squared minus 3. And I'm going to flip everybody else. So it's going to be a negative 1, a negative 2y squared, a positive 5y, and a positive y to the third. Now, as before, I'm going to identify my biggest degree. Seems like it's my y to the third. So I got y to the third. Going to cancel them out. I like to cross them out. I just feel like it's easier to see everybody else afterwards. Let's see, I got a negative 2y squared and a positive 4y squared. So 4y squared minus 2y squared will give me a 2y squared. Let's see, I got a 5y and a y. So 5 plus 1 will give me 6y. And I have a negative 3 minus 1, which will give me a negative 4. Okay, number 5 is something that people get tricked by so many times. It's subtract this from this, okay? So that 8b squared plus ab minus 2a squared goes before everybody else. So what I'm going to do is I'm going to write it properly in the right notation. So I have this piece right over here. I put him in front, right, because we are taking away from him. And I'm going to put this piece next. And notice how I'm putting parentheses. The reason why I'm doing that is so that you guys remember, oh, I have to distribute that negative sign. I can't forget to distribute. Because if you forget to distribute, you pretty much do all this work for no reason, okay? So, and here I'll color code this for you to make it cute. So there's that pink piece. And I cannot forget to distribute this negative sign right here. So I'm just going to change the signs for everybody that's pink, just because, you know, once we distribute that negative sign, it's what causes the sign change. So I have 8b squared plus ab minus 2a squared. And I'm going to change the sign for everybody in pink. So I have 10ab minus 7a squared plus b squared. Okay. And I'm going to do what I've been doing this entire time, right? I'm going to look for my highest degree. And again, like we said before in that last video, you need to make sure you're doing this in alphabetical order, right? So the A's are what's important, not the B. So I'm going to look for my A's. Who is my highest A? Well, it seems like I got a 2a squared and a negative 7a squared. So negative 2 minus 7 gives me negative 9a squared. Cross out, cross out. I have an AB and another AB. That's who's going to go next. I don't care that that B is squared because A will always come before B. So I have a positive AB plus 10AB. That will give me 11AB. And last but not least, I have an 8B squared plus B squared. That will give me a 9B squared. We're done. Okay. Be very careful when you see this word from, because I can't even tell you how many times I see kids mix that up. Okay, multiplying. You guys are pretty good with this. I just want to review it. I'm going to do the distribution method. If you guys want to look up FOIL, so FOIL is first, outer, inner, last. I'm just going to be going through the double distribution method because that is kind of the new way to do it. Not that it's really new or anything, it's just a way that I think the kids kind of remember the whole process a little bit better because it works with more terms than just a 2x2. You know, it'll work with a 3x3, it'll work with a 4x4. So if I just teach you that first way, you'll be able to apply it to more examples. So we're going to double distribute or triple distribute, whatever we need to do. We are still going to be combining like terms. Please don't forget to combine like terms. And last but not least, we're going to be writing our answers in standard form. So let's get started. I'm going to look at number 6. As said before, I'm going to distribute. So I'm going to take this first W and I'm going to distribute it to everybody that I see here. So I have W times W squared. That will give me W to the third. And as covered in that first video, we talked about exponent rules. When we are multiplying, we are really adding exponents. So this is really W to the first. So 1 plus 2 gives me 3. W times 2W this will give me, and they're both positive, so this will give me 2w squared, right? Because we have 1w here, another 1w over here. So w plus w gives me 2w. And now w times 1, I get back w, so we are good. So now let's talk about my next set. So I'm going to be distributing -7. Don't forget that sign, okay? So -7 times w squared times 2w and times 1. So I have a -7 times w squared will give me -7w squared. -7 times positive 2w will give me a -14w. And -7 times 1 will give me a -7. So now I'm going to go ahead, combine like terms. It seems like my w to the third is my biggest degree, so I'm going to put that first. Then I have w squared, so I have 2 minus 7, that will give me -5w squared. I have 1w minus 14w, that will give me -13w. And I have a -7. Okay. And if I were to name this, so say I did ask you to name this, this would be a cubic. Since we have 4 terms, this would be a polynomial. Not that the directions told you to name it, I just wanted to give you guys an example. Okay, 7. So I'm going to take care of this first chunk, and then I'm going to worry about my second chunk. So this is a situation where you could FOIL, but I'm going to do the distribution method. So I have 2x times 4, and then 2x times -9x. So 2x times 4 will give me 8x, and 2x times -9x will give me -18. X and x is 2 x's. So now I have to do my second piece, right? So I have 1 times 4 and 1 times -9x. So 1 times 4 will give me 4, and 1 times -9x will give me -9x. Okay, let's take care of this second piece. So I'm going to be distributing -2x into here. So I have a -2x. So there's actually 2 ways you could do this. You could just do 2x multiplying by 3x and 11. Doing the -2x though will kind of save you a step, so I'm just going to do that straight. So -2x times 3x, -2 times 3 is -6, and x times x is going to be x squared because we add those exponents. And -2 times 11 will give me a -22, and x is going to be tacked onto the end. So this looks pretty good. So I'm going to go ahead, combine like terms. I have 2 different squares, and that seems to be my leading degree. -18 minus 6 will give me -24, x squared. Cross, cross. 8x minus 9x gives me -x. Oh, I forgot something. And we have a -22, so that'll be -23x, so my bad. So I have this one, and this one. So -23x. And then I have my 4, so I'm just going to put him at the end. He's my constant. Okay, so let's take a look at number 8. So number 8, I'm just going to piece off these 2 and these 2. So I have a -3 times a plus 5. So I'm just going to go ahead and distribute that -3 in. So -3 times a will give me a -3a. And -3 times 5 will give me a -15. Now let's do the second piece. So I have my double distribution here, right? So I have a times a and a times 8. So a times a will give me a squared, and a times 8 will give me a positive 8a. The next thing I have to do is I have to look at -2 and distribute -2 to a and to 8. So -2 times a will be a -2a, and -2 times 18 will be a -16. Okay, so before I start multiplying anybody else, I can definitely combine these 2 just because, you know, like terms. So let's just write out my next piece. So I have -3a minus 15, and I have a squared plus 6a minus 16. Okay, time to distribute. So I'm going to start with this 3a, he's going to be multiplied by everybody here. Okay? So I have negative 3a times a squared. That will be a negative 3a to the third, because a to the first times a to the second. We add the exponents again, like I said before, give me the third. Negative 3a times 6a will give me a negative 18a squared. And negative 3a times negative 16 will give me a 48a. Okay, now let's do 15. So I have negative 15, and I will be distributing him to everybody here. Yeah, I know these get a little messy. That's why I'm trying to color code, make it look a little bit easier, a little more clear and concise. So negative 15 times a squared will give me a negative 15a squared. Negative 15 times 6a will give me negative 90a. And negative 15 times negative 16 gives me 240. Yep. Okay, so now let's just combine like terms. So I have, it seems like a to the third is my highest degree here. So I have negative 3a to the third. Let's see, I got an a squared here and an a squared here. Negative 18 minus 15 is negative 33a squared. 48a minus 90a is negative 42a. And we just have our 240 at the end. Okay. So let's see, 9. Okay, let's talk about this notation real quick. What the heck does this notation mean? Well, it means that I'm going to be seeing this part 3 times. Okay, so let's just write this out. This is really 2c plus 5d times 2c plus 5d times 2c plus 5d. To be very honest with you, you guys can try this yourself. I don't think I need to show you how to do this. It's just like number 8, to be very honest with you. I will write the answer down here for you. Try it. Try it on some paper. And if you guys don't get this answer, just text me and I'll write it out for you. So I got d plus 150cd squared plus 125d to the third. So you should end up with this, because when I did this problem before, this is what I got. So, give it a try if you want to give yourself a challenge. I have seen these actually on the ACT before, so, just try it. 10 and 11 are the same kind of deal, so I'm just going to leave you guys to your own devices. It's just a triple distribution, pretty standard. Now 12. 12 is kind of like a real life example of how you would use these polynomials in play. So for example, those variables could represent, different materials, something that you're actually building with. This is actually something very real life. Most engineers don't really work with real numbers until later on, which is pretty cool. So the height of a trapezoid, so let's see, that formula, so the area is 1/2 base plus height. Oh, no, it's base 1 plus base 2, that's what it is, times the height. Yeah, I don't really, geometry is not my thing, but I still remember these formulas. It's pretty good. So let's see, the height of a trapezoid can be expressed as 2x plus 9, while the bases can be expressed as 3x minus 7 and x plus 5. Write an expression to represent the area of a trapezoid. Okay, so I had a feeling this is going to be an area problem, that's why I wrote that down there. So let's see, I have my area is equal to 1/2 base 1 plus base 2. So it says the bases can be expressed by this number and this number. It doesn't matter who you number 1 and 2. It really doesn't matter. And they said this was the height. So I'm just going to be adding base 1 and base 2. So we have 3x minus 7. And we know with adding, the signs don't change, right? So I'm just going to put a plus sign, x plus 5. And this will be times the height, which is 2x plus 9. All right. So first things first, let's simplify this nonsense here. So I have 1/2 3x plus x will give me 4x. Oops. So I have 4x. Negative 7 plus 5 will give me a negative 2. I'm going to write down this other piece. And let's see. I'm going to, let's just multiply this piece by a half. So if I take half of 4, I will have 2. And if I take half of 2, I will have 1. And I still have this 2x plus 9. So what I did there was I just distributed this 1/2 right in here. And I just need to do it to one piece because you'll see that I'm going to be distributing the result to the next piece anyway. So it's some kind of like cool, tricky math that you can do once you get used to this stuff. So I clearly have a double distribution here. I'm going to pull that up here so we can write everything out nicely. So I have 2x minus 1, 2x plus 9, 2x to 2x, and 2x to 9. So let's see, 2x times 2x gives me 4x squared, and 2x times 9 will give me 18x. I'm going to do the same thing with this negative 1. I'm going to double distribute him. Negative 1 times 2x will be a negative 2x, and negative 1 times 9 will give me a negative 9. So I'm just going to combine like terms. So my area will be, let's see, 4x squared. These two can combine, so 18x minus 2x will give me 16x. And we still have this minus 9. So there's my area. Alright, so let's look at dividing polynomials. I do like dividing polynomials. I'm going to try to teach this to you guys the easiest way possible because I know a lot of you guys do not enjoy division. So let's give this a try. So particularly for you guys, I would write these out piece by piece. You know, if you're a little bit stronger with division, you know, you can just go straight. That's totally fine with me. So I'm going to write this out piece by piece to help you guys see this visually. So I have 9m to the third, and we are dividing him by 3m, minus 24m to the second divided by 3m. So I have 9 divided by 3, which is 3. And m to the third, because you know the quotient rule we have to subtract, right? So the third minus the first will give me to the second. Minus 24 divided by 3 will be 8. And m squared minus m to the first will give me just 1m. So we're done. So let's do this again. We have 3 pieces this time. So I have 20x to the third divided by 4x minus 4x squared divided by 4x minus 8x divided by 4x. 20 divided by 4 is 5. X to the third minus x to the first will give me x to the second. X squared 4 divided by 4 is 1. I'm not really going to put that 1 there. You know, we don't really write 1s. X squared minus x to the first will give me just an x to the first. And negative 8 divided by 4 will give me a negative 2. And we know our x's will cancel out because they'll turn into 1, because 1 minus 1 is x to the 0, and x to the 0 is 1. So there is our beautiful answer. Okay, 15. 15 looks so scary, but it's really, really not. So how we actually write this is I have 14, a to the fourth, b to the third, minus 20, a squared b squared plus 2ab. What does this mean? Well, as we said before, anything raised to a negative exponent, and maybe watch that part 1 video if you are looking at this like, what the heck is going on? This is our jump the line and change the sign. So since it was to the first, this is the same thing as 2ab to the first. So again, if we have a negative exponent, we jump the line, we change the sign. So this is really what's in my denominator. So I'm going to write this under everybody. So I have 2ab, 2ab, 2ab. So this is pretty close to when we were factoring, right? This looks identical. So 14 divided by 2 is 7. A to the fourth minus a will be a to the third. B to the third minus b will be b to the second. Minus 20 divided by 2 will give me 10. A squared minus a will give me a. B squared minus b will give me b. 2 divided by 2 goes away, turns into 1. AB, all that turns into 1. So 1 times 1 times 1, we're left with 1. So I'm going to go ahead and box that out. I'm going to, I'll do 16 too. I think 16 will be my last one just because 17 or 18, they're both pretty similar. Let's see. Yeah, you know what? I'll stick with 16. So I think, ironically, I think 16 is a little bit harder. The only difference between these is that 16 doesn't have, well, the answer won't have a negative exponent. So I'll just do this one. So let's see. I'm going to split this up. So I have 30c to the 8 d to the third all over 12c d, so c squared d, minus 36c to the 6 d squared all over 12c squared d, plus 6c to the third d all over 12c d, so c squared d. Good. Yep, and that looks great. So let's see. 30 divided by 12, that does not go in perfectly. It actually simplifies to be another fraction, so we have 5 over 2. We have c to the 8 minus c squared, because that is how the quotient rule works. So 8 minus 2 is 6. Since he's positive, he's going to stay on top. D to the third minus d. So we had 3, we're taking away 1. That is d squared. Minus 36 divided by 12. That does go in evenly. That will be 3. 6 minus 2 will give me 4. And 2 minus 1 will give me 1. And now 6 over 12, that simplifies to be 1/2. C to the third minus c squared, so 3 minus 2 is 1. And the d's cancel out, aka they become 1. So we are good. And I don't even sorry. I really don't even need this one, so I'm just going to erase him. 17, 18 are pretty much identical, so I'm going to let you guys try that on your own. So good luck with the activities. Feel free to reach out at any time, and I miss you guys.